So let's start looking at notations for the derivative. We've been doing this, right? F prime is y prime. And so we've been doing that d over dx. So that means take the derivative of y. So sometimes we write it dy over dx or d of dx of f. Remember, again, this means take the derivative of whatever follows, right? And so sometimes we use these big capital D's to say take the derivative. Oh my goodness, we're going to use second derivative? Yep, second derivative. And so it's going to be d squared or dxx, or this guy here is like saying d of dx of y. And you know this means y prime, right? And so I'd have y prime, and then I put another d of dx in front, that means you get second derivative. So that's all that d of dx, d over dx, sorry, I'm saying that wrong, means take the derivative. Okay, so if I have the function f of x, or s of t is the position, then one derivative is velocity, and two derivatives is acceleration. Okay, so let's use that application and see what we got here. Okay, here is the position function, and s is in meters, t is in seconds. Find the velocity function. So velocity is one derivative. So s prime of t is the same as v of t, so I just use the power rule. So I get 4t cubed minus 6t squared plus 2t minus 1. So that's the derivative, and that's the velocity. Oh, find the velocity after 2 seconds? Okay, so that means you're going to put in t equal 2. So I get 4 times 2 cubed minus 6 times 2 squared plus 2 times 2 minus 1. So figuring out this number, so I get 4 times 8 minus 6 times 4 plus 4 minus 1. So 32 minus 24 minus 3. So 32 minus 27. So that gives us 5. Positive 5, right? So I won't ever be a clincher about units, but it would be 5 meters per second, right? Because if we're talking about velocity. Okay, this next part says, whoops, find the acceleration. Okay, so acceleration is taking the second derivative. So I take the derivative of that. So v prime is a of t. So I get 12t squared minus 12t plus a 2. And after 1 second, I just plug in t equal 1. So I get 12 minus 12 plus 2, so I get 2. And acceleration is measured in meters per second squared. All right, so let's look at this one. So this says this is the position function, and they want us to find the acceleration when, oh, they're not giving us a time. So this is telling us what time to use, when the velocity is 0. Okay, I know how to find velocity. That's one derivative, so 3t squared minus 3. Velocity is 0, means set it equal to 0. And then I'm going to find out what that time is. So I get 3t squared equals 3. So t squared is 1. So when I take the square root, that's when I get the plus or minus 1, right? Oh, but this one says only for t's bigger than 0. So I'm going to use t equals 1. And where am I going to put that into? The acceleration. So let's go find the acceleration. So the acceleration will be the derivative of this. So 6t. Oh, I'm just going to plug in 1, and I get 6. And that would be in feet per second squared. Okay, so let's look at this one. Excuse me. So find the velocity. That's the goal. When, and this is the time, right? When the acceleration is 12 feet per second squared. Excuse me. All right, so let's do this. So that means I need to set the acceleration equal to 12. All right. So the acceleration we already know, so the same function, right? Acceleration we know is 6t. So if I set that equal to 12, doesn't that give me a t equal to 2? Oh, and that is bigger than 0. So then I need to go find the velocity. So my job is to plug in the time 2 into the velocity. This is the velocity. So v of 2 will be 3 times 2 squared minus 3. 3 times 4 minus 3, 12 minus 3 is 9. And that, again, that would be feet per second.